Hello and welcome to the last session of this sort of three-part workshop for the NCRM on text data analysis. So in the first video we covered some basics of Python. In the second video we took what we learned in the first one and built our first sort of very basic web scraper in order to extract the text data of user profiles on one of the University of Exeter staff pages. In this third part, we're going to start doing some very basic text analysis. Okay, we don't have time here to get into some of the more advanced techniques such as supervised learning methods and so on, but we are going to start covering some basic stuff upon which you can build as you go along. Okay, so this whole notion of text data analysis is linked to something known as natural language processing, or NLP, which is essentially a subfield which combines various aspects of artificial intelligence and linguistics, fields such as that. Okay, but in a practical sense, it's the whole idea of using technology, computers and algorithms and so on in order to understand natural language, i.e. human-produced language, okay, with the idea of being able to decipher, understand it, analyze it, and so on. And we see many applications of NLP in our day-to-day lives, such as our personal voice assistants, such as our Alexas, Google devices, and so on. Google Translate, that's just an advanced form of NLP. Microsoft, the spell checker and grammar checker in Microsoft Office, and so on and so forth. There are, however, some difficulties with NLP. Okay, firstly, it's not simple. Okay, it's a very natural language processing, i.e. getting computers that deal exclusively in zeros and ones to understand human language is intrinsically a very hard problem. Okay, but despite that, in recent decades, a large amount of progress has been made, particularly in the last 10 years or so. Some of these problems related to how related to the nature of linguistic rules for parsing and understanding language. Okay, and a large amount of our understanding of language use comes from context. Okay, so for example, sarcasm involves high levels of abstraction that computers don't understand. Elements such as that make NLP very difficult, and as such, a comprehensive understanding of human language requires both words and concepts in order to make sense of what is being said. Obviously, computers don't have access to these sort of mental constructs and concepts. Okay, and as such, they often make mistakes. An example is this. Okay, so we've got an English phrase here that says, "The spirit is willing, but the flesh is weak." You chuck that into something like Google Translate and ask it to translate into Russian, or you'll get the vodka is good, but the meat is rotten. Okay, because each of these have very specific concepts associated with them that the NLP algorithms in Google Translate haven't learned or haven't got access to. So it translates it as best as it can. Okay, and these kind of issues are due to how NLP works. Okay, because essentially it involves the application of the machine learning algorithms in order to identify and extract language rules. Okay, and therefore converting it into a form that computers can understand. Okay, this means that these algorithms are only as good as the sample set that's been trained upon. Okay, so for example, you might be able to train a sort of NLP algorithm on, I don't know, on a textbook for, I don't know, computer science, for example, and it will learn it. But then the language it learns, because it's only sort of learned the patterns in that textbook, it probably won't be able to understand language used in other forms of printed text, such as magazines and gossip columns, for example. So there will always be mistakes. Okay, and it's worth bearing that in mind as we go along. No natural language processing is perfect. However, as we're now living in an age of quote unquote big data, which is the buzzword everyone likes to throw around, we're having to use NLP more and more. And the reason for this is because when people say they are working with a big data set, most of the time they're actually referring to a text data set, so data that's been extracted from Twitter, for example, or YouTube comments, something like that. Okay, so and this has really driven some of the advancements in NLP in recent years. And like I said, there are now some really complex ways in order to visualize text data, such as word-to-vec algorithms, dialect models, and so on, which can be quite complicated and draw upon many concepts we see in machine learning. We don't have time to get into those today because this is meant to be a very basic introduction workshop. But I'm going to introduce you to some of the basic concepts that you sort of need to know before you can move on to that kind of stuff. Okay, so we're going to cover things like tokenization, Bygrams, Engrams, stuff like that. And then I'll show you something very trivial, such as how to make a word cloud, which people like to do, and so on. And then hopefully then this last part will then set you up to be able to learn some of the more advanced methods as you go along. So let's begin by importing the packages we're going to use. We won't use all of these packages, but we will use most of them, and I'll explain what each of the packages are as we go through instead of just listing them all off now. For the time being, we're just going to run them and load them all in. And we can see my little circle up here is dark grey / black, depending on the contrast of your screen. That means it's thinking, and it's gone hollow again, so it's finished thinking now, i.e. Python's finished loading in all the packages. Okay, first thing we're going to want to do is load in the data file that we created last time. So if you remember in video 2, the last thing we did was save our profiles as a text file in a JSON style format, where each profile is saved as a dictionary type object within a wider list. Okay, we're going to want to load that in, and we do that using pandas. Okay, so we've already imported pandas as PD here. So we say df equals pd.readJSON. Okay, now df is just computer scientist shorthand for data frame. That's all that means. Okay, and we're just going to call it data frame here because it makes sense. You can call it whatever you want. You could call this profiles data if you want, whatever. I'm just calling it data frames. We then say from the pandas package, we want to use the read_JSON function, which we're going to feed, and we're going to feed one argument into this, which is a string, which contains the location, the file location of my file, along with the file name and its type, which is .json. Okay, so we've got profiles.json, which we're loading in here. We run that line of code, and we can see it very quickly loaded the data in. Okay, I'm now going to print the data to the screen, and you can see that our JSON file, which is in this format here, has been loaded in. And what you can see, if I put this, that's not what I wanted to do. If I put this over here a little bit, you can see that it's taken each of the name keys in each of the dictionaries and it's put them all into one column. And if you scroll down here, you can see it's taken each of the page content keys and put that in a second column. And finally, it's taken each of the page URL keys and put them into a column there, and the same with position. Okay, so we've got 4 columns. Okay, it's, in other words, this readJSON function is read in our JSON format and our JSON file and create a data frame, whereby each of the 4 columns, are the individual's name, the contents of their page, the page URL, and their job title, which we call position. Okay, and then each of the rows is a different individual profile from the university's staff page. Okay, this command here, print list df, just tells Python to print the column names of the data frame. And if we scroll down, that's what this bit is here. You can see we've got 4 variables to play with. Okay. In this session today, we're just going to play around with the position title, okay? Because it's a nice simple variable which gives us some stuff to work with, and it will serve as a nice sort of introduction to text analysis. Okay, so for those of you who are familiar with standard statistical analysis, you'll know that before you go on and do your advanced statistical tests, such as your regressions and so on, you'll quite often do some descriptive statistics, okay? So calculate some measures of central tendency, print some graphs of distributions and so on. And you do these to get a feel for the data so you can see if there's anything odd, any outliers, or just the general layout of the data. You do a similar thing with text data, okay? Only we call it basic feature extraction. And this includes things such as, calculating word count, average word length, and so on. And just like descriptive statistical analysis and standard statistical analysis, the point of this is just to give you a feel for the data and what you're working with. So, the first thing we want to do is look at the word count. Okay, so we're going to look at our position field, and for each row, we're going to count the number of words contained within it. Okay, now it's important to note that each of the cells in this variable, okay, are saved as one. All the content is saved as one specific string. Okay, so this is the first column, and that's saved as for the first row, and that's saved as one string. This will be saved as also saved as one string, and so on and so forth. So in order to count the words here, we're going to use two of Python's inbuilt functions in tandem. We're going to use the split and the length function. Okay. Now, if we were to apply this to one string, we would write this bit of code that you can see right here. Okay, where x would be the string we're feeding in. Okay, so think of x as the string we're feeding in. Okay, so first time we're feeding in this text here: Professor of Anthropology, Sociology, and so on. Okay, and what this command says here is take x, split it wherever there's a white space. Okay, so wherever so it's got one string now, which includes each of the words and the white space. This command says split this string into separate strings wherever there's a white space. So now professor becomes its own string, anthropology becomes its own string, and whatever the other words are, each become their own string. Okay. We then feed that into this length command, which then gives us the number of individual strings contained in this new element we've created, which is in the form of a list. Okay, that's all that does. However, because we are working with a data frame, we obviously don't want to have to type this bit of code to do this to each of the individual rows in our data frame, because then we'd have to do it 118 times, and that requires too much effort. So what we do, we use the Lambda function. And the Lambda function works in a similar way to what functions do that we looked at in the first video. Only it's a way of easily applying. They're similar to the functions in the sense that they're a way of getting a piece of code to run on each of the individual elements in the sequence without having to do it manually. Okay, so that's what lambda x does here. It says take that variable and do this for each of the variables in whatever sequence we feed it in. Okay, so that's all that bit says there. What this bit says is that we're going to take our data frame and we're going to create a new column. And this column is going to be called word count. And it's going to be equal to the position column. Okay, but for each row in the position column, we're going to apply this function, which is going to be the one that splits the string and counts it. Okay, that's all that says. And if we run that, you will see. And yeah, we then assign that to this new variable name, and we then ask Python to print out this specific variable. And we see here we've got our new word count variable. Okay. Likewise, if I ask it to print out the whole data frame, df, okay, you can see here that we've gone from 4 columns to 5 columns because we've got this extra column here. And you can see here we've got the position, which was the last column in our original data frame, and we've got this nice new column added onto the end, which counts the words. And we can see here that, perhaps not a surprise, might be in the head of department, has the most to talk about in his job title, so he's got 39 words, and then I've got a lowly 4 because I am not that important. Okay, so then we want to do sort of an average word length. Okay, so you might see, looking at some of these words, you'll see things like professor and anthropology are quite long, things like data and of and are quite short. Although in this trivial example, you perhaps won't need average word length, when you start to analyze text data, so things such as Twitter posts or blog posts, for example, average word length can actually tell you a lot about how researched the post is. So, for example, blog posts that have a large average word length tend to indicate that these posts are using a large amount of scientific terms, and so that sort of gives you a bit of an initial insight into the nature of the text. And from that example, you can kind of see what I mean when I say these kind of steps are like the descriptive steps we see in normal traditional statistics. Now, in order to calculate average word length, we're going to build a little function, and hopefully you remember these functions from the first video. If you remember from that, we build their function by typing def, and then I'm going to call this function average word, and say that I'm going to feed in, my input's going to be a sentence. Okay? I then say my words are the sentence, and I'll call the split function. This is the same split function we called a moment ago, so that takes the string and divides the string into individual words for me. And if there are more than 0 words in the list, because some people have nothing in their position, in their job description name, if it's more than 0, then give me the sum of the length of each word in this list divided by the total number of words. Okay? So again, just calculating the average of it. And the way we call this and apply this to each of the rows in our data frame is exactly the same as how we did it a moment ago. We just specify a new column name called avwords, and we say we're going to apply this new function, average words, onto the position variable. If we run that, just like we did before, you can see we've got our new average word. So we can see that Mike, who we know is the first one there, has an average word length of 7.7 in his job title. I have an average of 5.5, which perhaps shows off how lazy I am at writing. Okay. Now, next thing you want to do is remove stop words. Okay. When you come to do text analysis on a large text corpus, you're going to want to remove stop words. And the reason this is twofold. One, sometimes they're not analytically interesting. Okay, so you're not interested in the use of and of and and so on. Secondly, when you come to supervised models, i.e. training algorithms in order to calculate various aspects and highlight certain features of text data, including these stop words, words such as and, the, of, and so on, can bias the algorithm and cause the algorithm to focus on these stop words instead of more analytically interesting words. Okay, so we just want to remove them. Okay, and there's a load of different ways in which you can do that. What we're going to use here is Nltk's stop word function. So if you look right over the top here, one of the things we imported was from the Nltk package, which is the natural language toolkit package in Python. We imported the stop words aspect of it. Okay. Now the Nltk package is a huge package, so you can't import the whole thing in one go. And even if you did, it would slow the code up quite a bit. So we import the specific functions we want. So we've imported the stop words function here. So we can just type stop words and it calls this package from the Nltk packet. So we scroll down here. And so, right, I've created a new variable called stop. And stop is all the English stop words from the Nltk stop.words function. Okay. So this basically says go to the stop words package, go to the words list and find me the English words, okay? And this produces a whole list of stop words that we see in the English language. So and, the, of, things like that. We then do, again, this lambda function exactly like we've done twice before, only this time we say for each of the words in our words list, if remove the x, i.e. remove the word if the word appears in this list. That's all this says here, okay? Here x refers to each of the specific words in our string, okay? So we split our string, and for each of the words in the string, if it appears in the stop list, okay, count it, okay? Count it for us, okay? And you can see here, again, Mike has like 10 stop words, so that's 10 and, there's, and so on. I have 1, that's because my job title is Lecturer in Data Analysis. In is a stop word, so that's the one stop word we've counted there, okay? And obviously, you can also do things such as remove these from the text if you so wanted to. But for the time being, I've just shown you how to access them. Special character count. So this isn't so much of an issue here because obviously job titles don't have many special characters in. But if you're analysing internet data, such as Twitter data or so on, you might want to count the number of special characters. Okay? And you can do that really easily with Python. Okay? You start off by creating a dictionary. Okay? Hopefully by now you've gotten used and comfortable to seeing dictionaries. I've created a dictionary of just 2 keyword pairs here, key value pairs here, just as an example. So we have our first key, which is hashtags, and it's a hashtag, and then our second key, which is Twitter name with a value of the @ symbol. Okay? And the reason I put this here is because if you know Twitter at all, you know that usernames start off with an @ symbol. Okay? I then say we'll cycle through each of the key value pairs in this dictionary. That's all this line says here, is cycle through each entry in the dictionary. And for each entry, create a new data frame with the name of the key, okay, and apply to our position column this function. And this function again says, split the position column into individual, so that each word is an individual list, just like we've done before. But if each of the words in that list, count it if it starts with one of these 2. Okay, so that will let you know whether or not you're counting whether or not a word is a hashtag or a username, for example. Okay, if we ask it to print, you see we've got that there. Okay, and again, if I print the data frame, okay, you can see, scroll down here, you can see our new columns have been added on, and we've got 1 for each of the special characters. And like I said, it's not a surprise that we don't have any of those in here. Okay, so uppercase count. Sometimes it can be useful to count the number of words that feature in a specific case. Okay, so if you think about people talking on the internet, okay, in YouTube comments or so on, often people will type in all uppercase in order to emphasize anger or something like that. So again, it's a very simple scripted count that can actually be quite useful. And fortunately, the Nltk package, which we've imported, has this cool function called isUpper, which basically just counts if a word is in uppercase, all in uppercase. And we apply this to each of individual words, just like we've done in all the other functions so far in this session, and create a new variable for it and run that. And you can see here, Mike has no uppercase characters. My colleague Alexei has 1. Whoever's here has none. I have none. Okay. Now at this point, it's worth remembering that we've created a lot of columns onto our data frame. So we might just want to just run some counts on the data frame to make sure we know what we're working with. The .shape function tells us the shape of the data frame, And you can see here, we still have 118 rows, so 118 profiles, but by doing the basic analysis we've done above, we've gone from 4 columns to 10 columns, okay? And we might go, okay, what are these new columns I've created again? Because, as computer scientists have very short memory. So we print off this list df again, and you can see the names of all our column names, okay? So these are the 4 that we generated from scraping the data in video 2, and then these are the ones we've created in this video here, which just adds descriptive stats, okay? And if we just wanted to see what this looks like in the data, we can print off the df.head, and that just gives us the first 5 rows of data in our data set, okay? So at this point we go, okay, yep, all these descriptive stats look good, okay, they look fine. And now we perhaps start to feel comfortable now that we've got a sort of feel for the data. We know what kind of data we're working with, we know how many average words we see, the number of stop words, whether or not there's special characters, and we've kind of got a feel for it, okay? So now we need to enter this sort of what we call the data pre-processing. And again, to draw an analogy with traditional statistical analysis, this is very similar to cleaning your data, okay? And those data analysts among you will know that cleaning your data is one of the most important steps in any data analysis project. And it is exactly the same here. If you don't get this step right, you can completely mess up your analysis, okay? Fortunately, there's a lot of good guides out there, and I'll link to some of these in the materials for the session. But if you follow the steps we're going to follow through now, 9 times out of 10, you'll be fine with your data. So the first thing we want to do is convert all of our text to lowercase. Okay, and this is because that if you remember way back in the first video from today, I said that when Python compares strings, it does so by looking for an exact match, okay? And so if one version of a text is in capitals and the other one is in lowercase, Python won't say it's a match because technically they are different strings, okay? So in order to avoid that and to avoid jeopardizing our future analysis, we want to break this down into, we want to convert each of these words in the position into lowercase, okay? And to do that, we just use the .lower command, okay? And you'll see this command looks exactly the same as the commands above it, okay? And that all we're doing here, well, we've kind of done 2 things first of all, actually. This is in 2 steps. So this bit here is very similar to the commands above, okay? In that we use the split command to break our sentence string down into individual strings where each string is a word. We then use the .lower command to make sure each of those words are converted into lowercase. We then feed all of that into this join command and say separate each of these words by a space in order to essentially reconstruct the sentence back to how it was, but with all lowercase characters, okay? And then the lambda works exactly the same way as it has before, and that just enables us to apply it to every row in the data frame. And if we run that, and I'll just see the first 5 records, you can see we've converted everything now into lowercase. So even the professors, the seniors, the lecturers, all these letters, first letters would often be capitals as well. They've all been converted now to lowercase. You can see that there. Okay. The next thing you want to do is remove those stop words we spoke about before. Okay. And this is for exactly the same reason I mentioned a moment ago, in that they can really sort of bias and skew your analysis. And you're also going to want to remove punctuation as well, because that can also cause havoc. So it's best just to remove it. Now, fortunately, the Nltk package makes this incredibly easy for us to do. So, however, I want to make sure that my stop words are fully comprehensive, okay? So what I do here, I create a new variable called NLTK list. And that is the stopwords list from the NLTK package, being the stopwords list that we saw a moment ago. Okay. There's another package we imported earlier on called word cloud, and that also has an inbuilt stopword list, which I'm also going to use, which I'm also going to call upon, which is this here. But I say instead of storing it in the JSON format which it is stored in, store it in a list format for me, the same as this one. I then say punctuation list, which is Python, one of Python's inbuilt punctuation lists. I'll convert that into a list as well. Okay. I then combine these three lists into one big list. However, because I'm analyzing this data, I suddenly become aware that there are some words that could appear in my analysis that I want to remove, but are unlikely to appear in standard stopword lists. So things such as HTTPS for the URLs, those are unlikely to be in the stopword list, but are likely to be in my data file, and I want to remove those. Same with the word website, and just some examples of punctuation here. So I create a fourth list, which is my own custom list, and I also add that to this list, and this then combines these four lists together to give me one big list of stopwords that I want to remove. Okay. Now that once we've got our stopword list, we can then do a similar function that we did before. Okay. So what does this do? So firstly, we call our split command, which does the same thing again of taking our sentence string and breaking it down into individual strings where each string is an individual word. We then say that we keep the word if that word is not in the stopword list. We then feed that all into this join command, which then combines each of the individual strings back together, but puts a space between them. Okay? And again, the lambda works exactly the same way as before. And if we print that off, you can see now that the stopwords have been removed. So in my job title, for example, I'm lecturer in data analysis, the in's been removed. Mike, I think, is professor of anthropology and so on, of's been removed. Okay, so we've removed the stop lists, the stop words. Okay, very nice and very simple. Now, that brings us to tokenization. You'll hear a lot about tokenization as you start to read more and more about textual analysis. That is essentially the process whereby we convert text data into a sequence of words or sentences. Okay? Now, for this example, we're going to again call upon the Nltk package, which, if you've not guessed by now, is a package you're going to use a lot when you come to do textual data analysis. Okay. Now, the Nltk package has a function called word_tokenize. Okay, and we can use this function in order to convert strings into tokens, i.e. individual words. Okay. Now, in order to make this work, we're going to have to loop through each of the rows in our data frame, and we'll then save the output of each row to a list. Okay. So if we run this, okay, you'll see all this is done here is essentially broken down each of the words in our column into separate individual token words or tokens we can work with. Okay. Now, on a basic level, this might look a lot like the split command we used a moment ago, but it's a little bit different in the fact that here it's not treating each one as an individual string, it's separating them as tokens, which is important for when you come to play around with some of the other Nltk functions. And you'll see why now when we start to look at this process of lemmatization. Okay. A, I can't pronounce it, and B, different people pronounce this word differently anyway. But it's essentially a way of stripping these various suffixes from words in order to break them down to their core root word. And this is important to do. So say, for example, you have So things like going will be broken down to go and so on, okay? Which again is important for analysis because although they're different words, they have the same meaning. And for our analysis, we may need to know what this meaning is, okay? As I say here on the slide, right, in more fancy terms, it makes sense to make use of it does sort of morphological analysis to obtain the root words, okay? And because of this, lemmatization is more commonly used than its sort of brother/sister method, which is known as stemming, okay? Stemming just chops the end off, which is fine until you encounter words such as caring, where if you just chop the suffix off of that, you get car, which has a very different meaning, okay? Lemmatization, however, uses the morphological meaning of the word to try and remove the suffix while maintaining the meaning of the word, okay? Now, we're going to run this operation on both the tokens column and our position column. And in both cases, we're going to overwrite the original column, okay? You don't have to. If you wanted to create a new column called, tokenized words or, lemmatized token words, whatever. But although we have to do a slightly different function for the two because of how they're laid out, remember one's token format, one's in normal string format, the process of calling dot lemmatize is exactly the same, okay? So here we call the Nltk function word with a capital W, parentheses, and we feed in each of the individual words in turn as created by the lambda function for x, and then call dot lemmatize on it. And if we were to print off, and it's going to take a second to run, and we print that off here. Do we see any examples here? We don't see many examples immediately because of the nature of the data set. But if there were words such as, teaching, for example, in any of these job titles, that would just now be teach. Okay, so that brings us to the end of text pre-processing. There are some other methods you might have to use as you use more complicated and advanced data sets. But that's the sort of basic fundamentals as things, fundamental sort of pre-processing aspects that you will have to do. Now, that brings us to text processing, okay, where we actually start to do, here we're actually going to start to do some actual textual analysis. And the first analysis method that's quite useful are what we call bygrams or engrams, okay? So these are a really useful way to evaluate which words co-occur together. So if you're using bygrams, you're looking at which two words appear a lot. So in our data set, you might expect to see senior and lecturer occur a lot. So they'd be quite a common bygram. Trigrams, combination of 3 words. Engrams, if you're looking at combinations of 4, 5, 6, whatever words. Okay, and there's a basic principle here that you can sort of see on the slide here, and that principle is that engrams capture language structure, okay? i.e. what letter or word is most likely to follow another one under consideration, okay? It's worth noting that the higher the n in engrams, quite often the less insightful it tends to be. Equally, sometimes bygrams aren't that useful. It's all about finding the sort of sweet n, and that there's no scientific way to work out what that is, I'm afraid. It's just it involves just a little bit of play just to see what works. Fortunately, thanks to Nltk, calculating engrams in text data is incredibly easy. So this code looks like a lot here, but we're doing a lot with this code, okay? So first things first, here this BGS thing here is how we calculate the bygrams, okay? So we feed in what we're saying is that for each row in the data frame, okay, so for each row, i.e. each profile in the data frame, okay, we're going to go to the tokens column, and all the tokens in that cell, we're going to calculate each combination of 2 words, Okay, we're then going to calculate the frequency at which each of these two words occur, and then we're going to create a new, which will be saved as a dictionary. We're then going to create a new data frame for each individual profile, which holds the engrams for each one. Okay, actually, just as a teaching example, because if I run this now, it's going to run on all 118 records, and it's going to take a while to run. So this code here, as it stands, is to run these operations on every single row in the data frame. I'm just going to make sure it only operates on the first row, i.e. just on Mike's account, Mike's profile, just so we're just looking at one example while we learn. But bear in mind, if you left this code as it was, it would run on each of the individual profiles. Okay, so I'm just going to run that. Okay, and so this. Okay, so this calculates the engram, the bygrams, because we're doing 2. Okay, this line here calls the pandas function data frame from dict, which is just a pandas function for taking a dictionary and converting it into a data frame. Okay, this line here, okay, organizes our data frame by the highest value. Okay, it organizes it from the highest value to the lowest value. And when I say value here, I'm talking about the value in the key value pairs. Okay, it just happens that in this case, the values happen to be the frequency of which they occur. So this creates a list whereby the most frequently occurring bygrams are at the top, going down to the least frequently occurring. Okay. This here gets the name of the profile. So in this case, this will be Mike's name, and we just use that name to create a string that we can name the new data file we're going to create for the specific account. We then export this as a CSV file, just like we did before with the Json file at the end of video 2. And once all that's run, then we go to our folder. You'll see we have a new file here. And you can see this file name it's called engrams _fric_, short for frequency. And we say plus profile name because it's taken Michael's name and then .csv as I've asked it to add onto the end. And if we open that, you can see it's saved bygrams breakdown on a file for us. And like I said, if you left this as it was, it would run through all of this for every single profile. So you would have 118 of these files, one for each individual profile. Okay. Here, I've just asked it to give me the 20 most frequently occurring bygrams. Okay. We're using very small data sets here, so it's not an issue. But if you're dealing with data sets that have, like a blog, if you scraped a blog website, for example, that has 300,000 posts, you might only want the top X number of bygrams just to sort of whittle it down a little bit, so this makes it easier to interpret. Okay. All this here then is just me visualizing the network. Okay. You quite often don't need to do this, but I just thought I'd do this to sort of as a teaching example. This code is pretty self-explanatory, but it's just using, if you Google Python's network X package, you'll see this code here is the basic default code you see on the website to activate it. And all this does is take each of the bygrams, work out which word is a bygram with which, and then creates a network of it. And then creates a network of it and then plots that network as an image to create this. Okay, so all that's done is it's worked out, right, that the words biomedical work with biotechnological are a bygram. It's also worked out that biotechnological and technoscience are also a bygram. So it's created this network by combining the two biotechnological nodes together and connected it to biomedical and technoscience. Equally, it's worked out that biomedical is a bigram with innovation, and that engage, I think that's public, and innovation are also a bigram and connected on innovation again. And it's done that for each of the bigrams to create this network of co-occurring words. Okay? And like I said, this here, if you Google Python network X, this is the default code to create a network image. It's nothing special. I literally copied and pasted it in. And this line here saves the network. So if you go back to your directory where everything worked, you'll see that that network image has been saved for you. Okay, and again, like I said, this is being run on. If you didn't alter this code, this would be run on every single profile, so you'd have 118 of these images. Okay, hope you see now why I only ran it on the first one for teaching purposes. Speaking of which, I'm going to do the same for this example here. Otherwise, we're going to be all day while this runs. Now, what I'm going to do here is just create a heat map of terms. Okay, so this is again just taking our bigrams exactly the same as before, taking the most frequent ones, and all it's doing is creating a co-occurrence matrix. So for those of you who do statistical analysis and have run a correlation test before, you know you create heat table correlations. This is exactly the same process as that, and it enables you to see which words sort of co-occur together. Some people prefer heat maps. I prefer the sort of network breakdown. I find that's a little bit more useful because it sort of shows which words occur with which, but obviously this shows the frequency. So we see here that technology more frequently occurs with science and so on. Okay, it's not often you create heat maps, so I'm just going to breeze past that a little bit. Term frequency is a very useful piece of analysis. Okay, so term frequency is merely the ratio that a specific word occurs as a function of the length of the sentence, i.e., how many times does that word appear in the document as a function of the overall number of words in the document. Okay, and so the code for calculating it is really easy. So we create first a for loop, and this again just goes through each row in our data frame. But again, I'm only going to do it on the first row, save us some processing time while we're teaching. So it says for each row in our data frame, create a dictionary called term frequency dictionary, which is empty. It then goes to our tokens list and it gets a list set of it. Okay. In Python, function set will take a sequence and it will create a new sequence which only contains one occurrence of each element in that sequence. So let's say you have a sentence that says, the cat sat on the cat. If you feed that into the set argument, it will produce a list that says the cat sat on the, because cat's already in there. It only contains one occurrence of each element, and it feeds it into the list. Okay. We then say for each token in this term list, count the number of times that token appears in our token cell for this row. Okay, and then divide that count, the amount of times it occurs, by the number of words in that cell. Okay. Here, I've asked it to count it as it occurs as the number of unique terms. So here it's going to count the frequency of it of the whole sentence. So the cat sat on the cat. Equally here, I've asked it to count the number of times it's been as a unique, number of times it occurs as a unique element, which, as I say out loud, I can't remember exactly what I did. It's not really that useful. This is the best one to go for. Anyway, it then saves these as a list and saves it into our dictionary. Okay. I then create a new data frame of this. Again, sort the values. So here, it just creates a data frame. It then takes the values and just reorders the data frame so that those words that most frequently occur at the top of the data frame and those that least frequently occur at the bottom. I do exactly the same thing we did before in order to get the name of the profile to feed into the file name and then export it as a CSV file. And if I run that, and then again go to our folder, you'll see that we've got term frequency here, and you can see it calculates the ratios of the amount of times those words appear for us. And like I said again, if you didn't change this bit here, you'd have 118 of those files, one for each profile. Right. I'm just going to show you, just before we get on to our conclusion section, I'm just going to show you how to create a word cloud. Now, it's worth noting that if you do actual textual analysis for a research paper or so on, don't use a word cloud because they're analytically not that interesting. However, they are quite popular in certain circles or for like PR advertising of your research papers and so on because they're eye-catchy. So it's worth knowing how to create one, and especially since it's incredibly simple. To do that, we just use the word cloud package, which we imported right at the very start, and we call the word cloud function. And if you Google the word cloud Python package and the word cloud function, you'll see that you've got all these different variables here, and these just adjust the image. Okay, so it's how big do you want the maximum word font size to be? So obviously, different words are different sizes in word clouds depending on how frequently they occur. So this just says how big do you want the maximum one to be, and I've just set it to 50. How wide do you want the image to be? How tall do you want it to be? What background color you want? Stuff like that. And then you just put dot generate and do that from this row, from this cell here, this column, this row, so this specific cell here. And again, all these is just to adjust the figure size, length, color, and to save the file. I'm again just only going to run this on the first profile. We run that, and you see it produces our word cloud for Mike's profile. Okay. Likewise, again, if you left this here, you get 118 of these, one for each of the different profiles. So, for example, if I was to put, let's do mine. So if I put 4 and on that, you see that I get a very small word cloud because my job title, I've only got 4 words in it, one of which is in, which has been removed. Okay. In short, Mike has a much more interesting job title than I have. Okay, so that brings us to our final piece for today, where we're going to look at some sentiment analysis. Now, it's worth noting that the sentiment analysis I'm going to show you how to do here is a very, very, very basic form of sentiment analysis. And it's the kind of sentiment analysis you do just to start off with, just to get a feel for what you're looking at. Okay, so we're still very much in that descriptive realm of this. And the reason for that is because there's a whole host of different sentiment analysis methods you can use, using either unsupervised or semi-supervised approaches. And we'll need a lot more than the 3 hours we've been allocated today in order to go through that. So I'm just going to show you how to do a very basic analysis using the text blob package in Python. Okay, so what does this do? Okay, well here we're going to, like I said, be using the text blob package just to do a quick piece of analysis. Okay, and this code here basically returns a tuple for each of our rows. Okay, and this tuple contains 2 numbers. Okay, the first number represents the polarity, and the second number represents the subjectivity of the whatever document you're feeding into it. Okay. Now, for the time being, at this point in our analysis, the only number we're actually interested in is the polarity, as this is what indicates the sentiment. Okay. The closer the polarity number is to -1, the more negative the document is. Likewise, the closer it is to 1, the more positive it is. And obviously, if it's 0, then it's sort of neutral. Okay. And I'm only showing you this now because this sort of forms the basis of some of the more complicated machine learning based sentiment analysis that come later. So if I just run that and print that off, and you see our polarity here. And it's perhaps no surprise that most of these numbers are very close to 0 because, you know, these are job titles, right? It's hard to have emotion in a job title. And here we're just going to add this to our data frame. And yeah, we just create a new data frame of it, which makes it look pretty. The reason I've showed you how to do this is because this is how you perhaps want to represent this in a paper if you were going to include sentiment analysis in there. And you can see your text there and sentiment there. Okay? Okay, so that brings us to the end of this session. I apologise that it's very, very rushed, but obviously we've had to cover a lot in the 3 hours we've had. Yeah, the whole purpose of this session was to provide you someone who's never done any text analysis before with the tools to start doing some very, very basic stuff. So we've covered a brief introduction to Python, how to build a very basic web scraper, and how to do some very basic descriptive level text analysis. There's a lot to build on from here. I'd recommend, like I said before in the last video, I'd recommend looking at the links I've provided in the first video that take you to, don't have a link here, that take you to the content. If you look at the first video in the first Jupyter notebook, that contains links that will take you to a page that has a lot more, tutorials in. So if I open that up here, yeah, if you go to this address here, you'll see that there's other introductions to Python that I've recorded, which are much more in depth than the one you got in the first session. And there's also some text analysis stuff here, which is more advanced than what we've had a chance to cover here. Yeah, this is being intended to serve as a very brief introduction, and hopefully you found it useful. If you have any questions, please feel free to contact me via email. I'm always happy to help as and when I can. Yeah, hopefully you found it useful. Thanks a lot, and have a good day.